Hello everyone. In our last video, we already show you how to make Acer latch and convert that Acer latch to Acer flip-flop, and then we made a D flip-flop by using a Acer flip-flop. In today's video, we will make a JK flip-flop. Okay. So first, draw the circuit diagram of a JK flip-flop. For the JK flip-flop also, the latch circuit is the same, right? The basic item. But we need a 3-input NAND gate for this JK flip-flop. Why? We have a feedback from the output. And why we need this one? Please write down in the comment box why we need a feedback to make a JK flip-flop. That means this one will be Q and this one will be Q bar. This will be J and this will be K and this will be the clock, right? So in the circuit you can see this is our latch, right? The same latch we used to make a Acer flip-flop, okay? And after that one, here we use a NAND gate of 3 input as we need a feedback, okay? So our design criteria will be, we will use a 2 input NAND gate, two input NAND gate. That means we will use a 7400 IC and 7410 IC. This 7410 is a 3 input NAND gate, okay, and this one is a 2 input NAND gate, right? For the 7400, we all know the pin configuration is like this one, right? Here you can see this one is a 7400 IC. We use this IC to make the Acer flip-flop and D flip-flop, right? Where number 1 and number 2 is the input and number 3 is the output. Similarly, 4, 5 input, 6 output, 8 is the output, 9, 10 is input, 12, 13 is input, 11 is the output, right? And we need to give the VCC on number 14 pin and number 7 pin is the ground, right? So we already know how to use this 7400 IC, but till now we didn't use the 7410 IC. So I take the screenshot from the data sheet. Here you can see this one is the 7410 IC, and you can see here triple 3 input NAND gate. That means in this IC 7410 we have three input NAND gates. Okay. So for the NAND gate, you can see here number 1 and number 2 and number 13 is the input of the first NAND gate and the output will be number 12. So when you will give the examination, at that time, please draw the pin configuration in your exam sheet. And you need to remember this pin configuration. This one will be number 1 and this one will be number 2. Okay. And this will be the number 3. Here you can see that number 2 and number 3, these two NAND gate, all the pins of number 2 in the bottom side, and for the number 3 all the pins is in the top side, right? But for the number 1, some pins in bottom, some pins in the top, right? So I will suggest you not to use the number 1 as it can create the confusion. But number 2 you can see 3, 4, 5 continuous is the input, 6 is the output, and for the number 3, 9, 10, 11 is the input and 8 is the output. As these two is just similar like the our NAND gate 7400 IC, right? So I will prefer to use the number 2 and number 3. Okay, so this is the pin configuration of the 7410 IC. Okay, and this will be our first step. That means first make a latch and check the output. This will be our first criteria, and then we will connect a 7410 IC and then we will check the actual output of the JK flip-flop. Okay, so let's go to the breadboard. First you can see here, this is our D flip-flop, right? In our last video, we made a D flip-flop by using this one. So first, our job is the remove all of the cables. So I will remove this IC. So whenever you try to remove the IC, don't remove by like this, okay, from the top. Use a pen or screwdriver and from here just lift little bit. So you can see the IC is already take out. Okay. So this one is 7400 IC, and we already checked this IC in our last video. It is completely fine. If you didn't saw that video, I will add that one in the description box and also in the I button. So first I connect this IC little bit left side. Okay, no problem. I didn't remove the LEDs. Okay, as this will be our Q and Q bar in all of the videos. So first our job is to connect the power supply, right? So I connect it. I connect the VCC to the number 14 pin and connect the ground in the number 7 pin. Okay, the orange one is the power supply. No problem. Now we need to make a latch, right? So we will use the first and the second flip-flop. Okay, the first one we all know that to make the latch, go to the screen. This is the latch circuit. Okay, here I put the pin configuration or the pin number. So this will be number 1 pin, number 2 and number 3, 4, 5 and 6. Okay, so here you can see that number 3 is connected with the number 4. Okay, so connect the pin number 3 to number 4. You can see number 3 is connected with the number 4 already. And the number 2 is connected with the number 6. Number 2, that means this one, connected with the number 6. So I already shot the output and the inputs. Okay. Now the number 1 will be our latch input. So I connect the blue one in the number 1. So this is our number 1. I connect another blue one for the input will be number 5. So here number 5 is only one left here. So connect here to number 5. Okay. So this will be our, for the latch point of view, this will be our R and this will be our S, right? For the latch point of view, this will be R, this will be R and this will be S. Okay. So the blue one, this blue one, okay, the left side blue one is the R, the right side blue one is S. Okay. And connect the output. The output I will make a red one. For the Q, it will be connected with the red one. You can see that this LED will be our Q. This one will be connected with the number 3 pin, right? So here we have number 3. This one, okay. And the Q bar will be connected from the number 6 pin. So this is number 6 and it will be connected to Q bar. Okay, no problem. So I already made the latch circuit. RS latch or SR latch circuit I already made. Okay, no problem. First need to check this latch circuit. To check the latch circuit, I need a truth table, right? For the truth table, R, S, Q, Q bar. 0, 0, it will be 1, 1. 0, 1, it will be 1, 0. 1, 0, then 0, 1. And then 1, 1 will be our memory. Okay. So first try to set the latch. That means R equal to 0 and S equal to 1. Right. So R equal to 0 and S is equal to 1. So you can see our latch is set as the red LED is on, the white one is the off. Okay, no problem. So now the latch is already set, right? Now try to reset the latch. To reset the latch, you can see here in the S pin we have 0 and R is 1. right? Okay, so here we need to change the R from 0 to 1, R from 0 to 1, and change the S from 1 to 0. You can see here the output is reset and we have Q bar is turned on as the S is 0, R is 1. Okay, now let's check the memory condition. For the memory, if I connect the S with the 1, then the output should be the same. You can see the output didn't change. Now R and S both 1 1 and it satisfied our truth table, right? Now the next condition is 0 0. If I give 0 0 in S and R, then both the output should be on, right? Let's see. You can see S and R both 0 0, and you can see here the both the LEDs turned on. That means we can say our latch circuit is completely working fine. No problem with the latch circuit. Okay. Now let's build the other part of the circuit. That means with the 3 input NAND gate one. Okay. So if I go to the screen, you can see here this portion. We need to make this portion now. Okay. And then we will connect the output of this one with the number 1 and connect the output of this one with the number 5. Okay, so this one is the number 1, right? And this one will be our number 5. This is R and this is S, these two, right? Now let's build that one. So whenever we make any circuit, first take out the power supply. If there is any fault, then our IC can be burned. Okay, here I take a 7410 IC. In the bottom breadboard, I connect a 7410 IC. Okay, so for this IC also, this is the notch, right? So that means this is the number 1 pin, number 7, number 8, and number 14 pin. Okay, so first give the power supply to this IC. That means the number 7 pin will go to the ground. Okay, and the number 14 pin will go to the VCC. Okay, so I already connect the power supply to the IC. Now let's go to the pin configuration in the screen. I already told you we will use number 2 and number 3 NAND gate, right? For the number 2, 3, 4 and 5 and 6 will be the output, and number 3, 9, 10, 11 is the input, number 8 is the output, right? So let's draw this one. For the first NAND gate here, number 3, number 4 and number 5. J will be number 4, okay? And the 6 will be connected with the latch. This will be number 8 will be the output, and 9, 10 and 11. Okay, so let's make this one. For the J and K, I will use, so I will make this yellow one as a J and this green one as a K. Okay, so the K is number 10. So the number 10 is K. That means this one is the number 8, 9, 10. So here 8, 9 and 10. So this is K. Okay, and J is number 4. 0, 1, 2, 3, 4. So this is our J. Number 6 will be connected with the R, that means the 1, this one. This is our R, right? And this one is the number 1 pin of our above NAND gate. Okay? So connect this one with the number 6. You can see I already connected with the number 6. Okay? And the number 5 will connect with the 8. So this is our number 5 and this will be connected with the 8. Okay? No problem. Now in the circuit you can see there is a feedback from Q to number 11 and Q bar to number 3, right? Q means the output. That means this is our Q, the red one, this Q out. Okay, it will be connected with the number 11 pin, right? So now here this is 8, 9, 10, and this one will be 11. The Q bar, this feedback, the Q bar feedback, this will go to number 3. Number 3 is, this one is number 3, the bottom, and this will go to the Q bar. Q bar is just before the resistance. Okay, so here this will be our Q bar, right? Q bar I connected with the number 3 pin, no problem. I connect the Q with the number 11 pin, so the feedback is done, no problem. Now we already made J, we already made K, we already give the feedback from Q to number 11 and Q bar to number 3, no problem. But now we need a clock pulse, right? So we need to make a clock pulse again. So this red one will be our clock pulse, and the clock pulse value will be either 1 or 0, right? To make that one, I will use 1 on this side and 0 for this side. Okay, now the clock pulse will connect it to the number 5 and 9, right? So we need to short the number 5 and 9. So number 5 pin is 1, 2, 3, 4, 5. So this is number 5, and the in the above this is number 9. Okay, so number 5 and 9 is shorted with this wire, no problem. Now connect the clock pulse from the number 5 pin. So you already built the circuit. You can see this is the complete circuit, and in this circuit the yellow one is our J, the green one is our K, okay, and this blue one is our clock pulse. Okay, if I connect this blue wire with the right side of this circuit, then it will be clock 1, and if I move this one to the left side of this circuit, that means this side, then it will be clock 0. Okay, so let's see. First we need to give the power supply to this circuit. You can see you already give the power supply, okay, and some of the LEDs turned on, don't care about that one. Now we need to connect this J and K with the 0011 like this, right? And you can see here this bar, this one is our 1 and this bar is our 0, as I just tapped from the above breadboard. Okay, so we don't need to connect this to the above breadboard. Okay, so now we need to check this flip-flop is working fine or not. So to check this one, we need to make a truth table. If clock, this is first is clock J and K, right? Then Qn plus 1 and Qn plus 1 bar. Okay, so if clock is 0, then J and K don't care, output will be memory. No problem. If clock is 1, J 0, K 0, then it will be memory. But if clock 1, J0, K1, the output will be 1, 0, and the Q bar is 1. Clock 1, 1 and 0, then it will be set. Okay, and 1 and 1, it will be toggle state. But though we cannot see the toggle here, so that means this will be our toggle. Okay, this will be our set, and this will be our reset, right? And this will be memory. Okay, so let's check first with the reset condition. That means J will be 0, K will be 1. So this yellow one is our J and this will be K, right? So first make the clock pulse 1. You can see the blue LED is already turned on as the clock pulse is 1. Now make J is 0 and K is, you can see J is 0, K is 1. The output is reset, right? That means Q bar is 1, right? Now if I remove the clock pulse, then the output should not be changed, right? The output should be in memory state, right? This blue is the clock pulse. So if I take out this one, so you can see the clock is 0 and output is same, right? And to satisfy the first condition, that means if the clock is 0, whatever we change, the output should not be changed, right? Now first connect the clock pulse to 0, okay, and then change the J to 1 1. You can see now J and K both is 1 1, output didn't change. And also if I change the K from 1 to 0, that means this should be the set condition, but you can see the output still not change as the clock pulse is 0, right? Now J is 1, then K is 0. Output should be set, but output is reset condition as the clock pulse is 0, okay? Now if I change the clock from 0 to 1, then the output should be set. So you can see here, if I change it and make it 1, you can see the clock is 1, output is set as the red LED is already turned on, right? So our set condition is satisfied, reset is also satisfied, right? Now let's see with the toggle. So what we need to do, just connect J and K both 1 1. So you can see here, now currently J and K both is equal to 1 1, right? And we can see the clock is 1, output is in the toggle state, but we cannot see the toggle as this toggle is very fast. So our naked eye cannot catch this toggling, okay? So this is the practical of the JK flip-flop, and we made this JK flip-flop by using 7400 and 7410 IC, okay? Now let's build a T flip-flop. For the T flip-flop, what we need to do? It will be very easy. For T, we just need to short the J and K by some wire, okay, and then this J will called as T. Let's make that one. First J and K should be shorted, right? That means this is J and I need to short the K also. So this green one is our K, so I just short this 2 pin, okay? So you can see J and K is shorted. So you can see J and K are shorted, right? Now this point will be our T. So this new yellow one is our T. So now this is the T flip-flop and this is the input T input, okay? So for the T input, if I give value 1, then the output should be toggle, okay? And if I give the value of 0, then output should be memory, right? So value of T, you can see. So I connect it to the 1, but we cannot see the toggle. Why? The toggling is there, but our naked eye cannot catch this toggling, okay? And if I change the 1 to 0, then this will be in the memory state. But when you give the value t equal to 0, you can see here the output is how much? Is 0 and 1. Why? It's just like this. When the toggling is happening, at the end of the clock pulse, when I change the value of t from 1 to 0, at that time the output should be in this position. That means the output should be in the 0 position. So when I make t equal to 0, it just continues. Okay? So that's how we get here q is 0 and q bar is 1. Okay? Now let's change again from 0 to 1. You can see output is again in the toggle state. Okay? And now change it to 1 to 0 again. You can see here this time we find out this one is 1, this one is 0. Why? When we change the clock pulse, maybe at that time the output is at one state, and at that time we change it to 1 to 0, so it become the memory state. Okay, so to check the T flip-flop output, it's better to use a CRO, but now I don't have a CRO, so I cannot show you the toggling. Okay, so that's all for this JK flip-flop and T flip-flop video. The circuit diagram, I already show you how to make a circuit diagram and how to check the pin configuration, write down the pin, and I also write down the pin number in the circuit diagrams. Okay, and then I first made the latch, then convert it to the JK flip-flop, and then short the J and K to make a T flip-flop. Okay, so that's all for this video. See you in the next one. Thanks for your time. Please do share this concept with your friends. And if you like this video, please press the like button. It is really means a lot for me. Bye bye.